National Electrical Code Section 780 covers power systems used in telecommunications and provides requirements for grounding, bonding, and protection of equipment. NFPA 70, commonly known as the National Electrical Code, addresses electrical wiring, equipment, and installations in general, including grounding and bonding practices. The ICC Electrical Code addresses electrical requirements for buildings, including provisions for grounding and bonding. Local and state building codes may have specific requirements for electrical installations, including grounding and bonding practices. National Electrical Code Section 780.140 ATWA requires that return circuits of DC power systems be bonded together within the equipment cabinet or rack. National Electrical Code Section 780.140 AFI permits bonding of returned circuits to the equipment enclosure, provided the enclosure is adequately grounded. National Electrical Code Section 780.160 requires that telecommunications equipment be bonded to the grounding electrode system of the building. NFPA 70 Article 250 covers grounding and bonding requirements for electrical systems. NFPA 70 Part Roman 3 Article 300 specifically addresses grounding and bonding of electrical equipment. IC Section R 302.5 requires that electrical equipment be grounded using approved methods, including bonding to the grounding electrode system. IC Section R 302.5 ATWA permits bonding of grounding conductors to the building steel if it meets the requirements for the grounding electrode system. The practice of bonding returned circuits to building steel and piping raises concerns about electrolysis. Electrolysis occurs when an electric current flows through a liquid, causing the decomposition of the liquid and the release of hydrogen and oxygen. In this case, the liquid would be any moisture present on the building steel or piping. Electrolysis can weaken the metal and lead to corrosion. While the NEC and other codes permit bonding of returned circuits to the equipment enclosure and building steel, it is generally considered best practice to avoid bonding them directly to the building piping system. Instead, consider the following recommendations. Firstly, bond the return circuits to the equipment enclosure and ground the enclosure to the building grounding electrode system. Secondly, use non-conducting isolation washers or pads between the equipment and the building floor to minimize any possible current flow through the building steel. Thirdly, monitor the building steel and piping for signs of corrosion or damage. And fourthly, consult with a qualified electrical engineer or building official to ensure compliance with all applicable codes and to address any specific concerns. Bonding all the returned circuits and directly bonding the equipment to the building steel and bolting to the floor without isolators intentionally allows several amps of direct current to flow through the building steel and piping systems. This is a terrible idea and will lead to electrolysis and degrading the building pipes and steel. Since this is negative 48 volts direct current, electrical or building codes issues may or may not allow this practice. Grounding and bonding are critical for electrical safety and equipment protection. These practices ensure that electrical systems operate safely and efficiently, minimizing the risk of electrical shock, fire hazards, and equipment damage. Firstly, grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices to quickly trip and clear the fault. Secondly, bonding connects all non-current carrying metal parts of an electrical system to create an electrically continuous path, reducing voltage differences and minimizing the risk of electric shock. The NEC, NFPA 70, and IC provide detailed requirements for grounding and bonding to ensure electrical safety in buildings. These codes specify the types of grounding electrodes that can be used, the size of grounding conductors, and the methods for bonding equipment and enclosures. It is important to comply with these codes to ensure that electrical systems are installed and maintained safely. Electrolysis is a chemical process that occurs when an electric current passes through an electrolyte, causing the decomposition of the electrolyte and the deposition of metal ions on an electrode. In the context of building infrastructure, electrolysis can occur when stray direct current flows through building steel or piping, causing corrosion and weakening of the metal. The risk of electrolysis is increased when returned circuits are intentionally bonded to building steel and piping, as this creates a path for direct current to flow through these structures. To minimize the risk of electrolysis, it is important to avoid bonding return circuits directly to building steel and piping. Instead, return circuits should be bonded to the equipment enclosure, and the enclosure should be grounded to the building grounding electrode system. This provides a low impedance path for fault currents to return to the source without flowing through building steel or piping. Isolation washers or pads can be used to minimize any possible current flow through building steel. These devices provide an insulating barrier between the equipment and the building floor, preventing direct contact and reducing the risk of current flow. It is also important to monitor building steel and piping for signs of corrosion or damage. Regular inspections can help identify any potential problems early on, allowing for timely repairs and preventing further damage. It is always best to consult with a qualified electrical engineer or building official to ensure compliance with all applicable codes and to address any specific concerns. These professionals have the expertise to assess the specific risks and to recommend appropriate grounding and bonding practices. Grounding electrodes are conductive objects that are buried in the earth and used to establish a connection to ground. The NEC specifies the types of grounding electrodes that can be used, including metal underground water pipes, ground rings, rod and pipe electrodes, and plate electrodes. The grounding electrode system must be sized and installed in accordance with the NEC to ensure that it provides a low impedance path to ground. Grounding conductors are used to connect equipment and enclosures to the grounding electrode system. The NEC specifies the size and type of grounding conductors that must be used, depending on the size of the circuit and the type of equipment being grounded. Grounding conductors must be properly installed and protected from damage to ensure that they provide a reliable connection to ground. Bonding is the process of connecting all non-current carrying metal parts of an electrical system to create an electrically continuous path. This includes equipment enclosures, metal raceways, and other metal components. Bonding reduces voltage differences between metal parts and minimizes the risk of electric shock. Bonding jumpers are used to connect metal parts together to create a continuous electrical path. The NEC specifies the size and type of bonding jumpers that must be used depending on the size of the circuit and the type of equipment being bonded. Bonding jumpers must be properly installed and protected from damage to ensure that they provide a reliable connection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. These devices are designed to trip and interrupt the flow of current when a fault occurs, preventing damage to equipment and reducing the risk of fire. Overcurrent protection devices must be sized and installed in accordance with the NEC to ensure that they provide adequate protection. Electrical safety is a critical concern in all buildings, and proper grounding and bonding practices are essential for ensuring electrical safety. By following the requirements of the NEC, NFPA 70, and IEC, and by implementing appropriate grounding and bonding practices, it is possible to minimize the risk of electrical shock, fire hazards, and equipment damage. Regular inspections and maintenance are also important for ensuring that electrical systems continue to operate safely and efficiently. In addition to the NEC, NFPA 70, and IEC, there are other codes and standards that may be relevant to grounding and bonding in specific applications. These include the National Electrical Safety Code, which covers electrical safety in utility systems, and the Telecommunications Industry Standards, which cover grounding and bonding in telecommunications equipment. It is important to be aware of all applicable codes and standards and to comply with their requirements. Grounding and bonding are complex topics, and it is always best to consult with a qualified electrical engineer or building official to ensure that electrical systems are installed and maintained safely and in compliance with all applicable codes and standards. These professionals have the expertise to assess the specific risks and to recommend appropriate grounding and bonding practices. Here are some additional details on specific NEC sections related to telecommunications grounding and bonding. NEC Article 780 covers optical fiber cables and raceways. This article provides requirements for the installation of optical fiber cables and raceways, including grounding and bonding requirements. It's important to consult this article when dealing with optical fiber installations in telecommunications systems. NEC Article 800 covers communications circuits. This article provides requirements for the installation of communications circuits, including grounding and bonding requirements. It covers various types of communication circuits, such as telephone, data, and CAT-TV systems. NEC Section 800.100 addresses cable and primary protector grounding. This section specifies the grounding requirements for communications cables and primary protectors. It outlines the methods for grounding these components to ensure safety and proper system operation. NEC Section 800.40 covers installation of communications wires, cables, and equipment. This section provides requirements for the installation of communications wires, cables, and equipment, including grounding and bonding considerations. It addresses issues such as separation from power conductors and proper support and securing of cables. NEC Article 820 covers community antenna television, CAT-TV, and radio distribution systems. This article provides requirements for the installation of CAT-TV and radio distribution systems, including grounding and bonding requirements. It covers issues such as bonding of equipment and grounding of coaxial cables. It's essential to consider the specific requirements of these NEC sections when designing and installing telecommunications systems to ensure compliance and safety. Grounding electrode conductors connect the grounding electrode to the electrical system's grounded conductor, typically at the service equipment. They provide a low impedance path for fault current to return to the source. Equipment grounding conductors connect non-current carrying metal parts of equipment to the grounding system. This ensures that if a fault occurs, the fault current can quickly return to the source, tripping a breaker or fuse and preventing electrical shock. Bonding jumpers are used to connect different metal parts together, creating a continuous electrical path. This helps to minimize voltage differences and reduce the risk of electrical shock. Bonding can be achieved through various methods, such as using bonding bushings, bonding straps, or direct metal-to-metal contact. Grounding busbars serve as central connection points for grounding conductors within an electrical panel or enclosure. They provide a convenient and organized way to connect multiple grounding conductors to a common grounding point. Isolated ground receptacles are special types of receptacles that have their grounding terminal isolated from the normal equipment grounding system. They are often used in sensitive electronic equipment to minimize electrical noise and interference. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes or other transient events. They divert excess voltage to ground, preventing damage to sensitive electronic components. Proper grounding is essential for the effective operation of SPD. Static electricity can build up on non-conductive surfaces, posing a risk of damage to sensitive electronic equipment. Static control measures, such as grounding mats and wrist straps, are used to dissipate static electricity and prevent electrostatic discharge (ESD). Telecommunications rooms, also known as telecom closets, house telecommunications equipment such as servers, routers, and switches. Proper grounding and bonding are crucial in these rooms to ensure the reliable operation of telecommunications systems and to protect equipment from damage. Data centers are facilities that house large numbers of servers and other IT equipment. They require robust grounding and bonding systems to ensure the reliable operation of IT equipment and to protect against data loss or corruption. Industrial facilities often have complex electrical systems with heavy machinery and equipment. Proper grounding and bonding are essential for electrical safety and to prevent equipment damage in these environments. Healthcare facilities have stringent requirements for electrical safety to protect patients and staff from electrical shock hazards. Grounding and bonding systems in healthcare facilities must be carefully designed and maintained to ensure patient safety. Renewable energy systems, such as solar photovoltaic PV systems, require specialized grounding and bonding systems to ensure safety and to protect equipment from damage caused by lightning strikes or other transient events. Lightning protection systems are designed to protect buildings and structures from lightning strikes. They consist of lightning rods, conductors, and grounding electrodes that provide a path for lightning currents to flow safely to ground.